Hello, you are most welcome. I'm teacher Ivan from WUNNA Educational Services. Today we shall be looking at surds, logarithms, and indices. We shall start with the surds, and we shall look at how we simplify surds. For instance, we are told that simplify each of the following, and we have root 50. So for us to simplify root 50, this is the rule. We must get two numbers or two factors of 50. We get two factors of 50, but one of the two must be a square number. For instance, 50 has many factors. We have 2 and 25. We have 1 and 50. We have 5 and 10. But out of those pairs, where do we find a square number? It is only 2 and 25. Therefore, those factors that we shall use are 25 and 2, because 25 is a square number. So that means that 50 is 25 times 2, and therefore we separate. We get root 25 times root 2, which is 5, because root of 25 is 5 times root 2. So that gives us 5 root 2. Then we come to our second number, that is root 27. Still we do the same. We look for factors of 27, but one must be a square number, which is 9 and 3. So we separate the two. We get root 9 times root 3. Root 9 is 3 times root 3, which gives us 3 root 3. So that is how we simplify surds. And since we know how to simplify surds, you can try out this for your own practice. Let us look at how we add and subtract surds. This is what we should note. We only add or subtract surds if and only if the numbers under the roots are the same. We only add or subtract surds if and only if the numbers under the roots are the same. This is what I mean. For instance, we have 3 root 2 plus root 2. So you see that under the roots we have the same numbers. We have a 2. Therefore, we shall add the 3 root 2's plus a root 2 to give us 4 root 2. But if at all we had a different number, for instance, if we had 2 root 3 plus root 2, these are two unknowns, so we cannot add them. We only add or subtract surds if they have the same numbers under the roots. So after knowing that principle, let us look at examples. Our first example is 3 root 5 plus 7 root 5. So we can factorize out the common factor, which is root 5, into 3 plus 7 to get us root 5 times 10, which gives us 10 root 5. The same we do for subtraction. Since we have the same figures under the roots, we can factorize out the root. We get root 6 into 5 minus 11, which gives us root 6 times negative 6 hence giving us negative 6 root 6. So that is how we add or subtract surds. Then we also have instances where we have addition and subtraction in the same number. For instance, we have 4 root 2 minus 3 root 2 plus root 2. Still, it is a matter of factorizing out the common factor, which is root 2. Then you remain with 4 minus 3 plus 1, giving us root 2 into 1 plus 1, which gives us root 2 times 2, giving us the final answer as 2 root 2. The same applies to example 4. Now, in example 4, we have two different roots. We have root 2 and root 5. So we shall collect like a terms. We bring the root 2's together and root 5's together. That is, we shall have 9 root 2 minus 4 root 2 plus 5 root 2 plus 2 root 2. Sorry, plus 5 root 5 plus 2 root 5. So, in short, what I can see from what I've observed is that these roots are treated as unknowns, just like you may have 9x plus 5y minus 4x plus 2y. So the same way we treat these different roots. We collect like a terms and simplify. So this gives us 5 root 2 plus 7 root 5. So that is addition and subtraction of surds. So since you have mastered the concept, now you can try out this for your own practice. Otherwise, we meet in the next session. Thank you.